Alright, this is the Teacher's Edition video for the Yeast Invertase Lab. I have numbered 1 through 6 because I'm actually going to use all 6 tubes that I gave you for this lab. So many of you just use the first 3, and that's fine. You know, that's, like I said, that's how your lab went. So the whole part of this exercise was for you to create a protocol and see if you were able to get what you had out of it. And of course, there were some pieces missing, and they were missing on purpose because I enjoy your frustration. No, it's mainly I want to see how you process, one, when things aren't going well, or things you don't think are going well, and also that you fail. And it's important that you fail because that's what science is. People who do science, they tend to fail more than they succeed. Okay, usually any great discovery was preceded by failure after failure after failure. So now you guys have failed once, and that's okay. So now we're going to go ahead and take a look and see. With this video, you now have a little greater or you will have a little greater understanding as to how invertase works, and under what pHs you would you're going to maybe expect or not expect to see the hydrolysis occur. So in the first tube, I went ahead and I'm going to have the invertase, and I'm actually going to have the invertase in the first 3, similar to how you guys had it. Okay. The first 3 tubes are the ones that majority of you had in common. All 3, you know, the first 3 have invertase, and they all had, we could spell, sucrose, right? And then this is where you guys had your variable with the pH, okay? Some of you decided to go with adding distilled water for your neutral, okay? Some had hydrochloric acid here and sodium hydroxide here. So the sodium hydroxide obviously referring to an alkaline or a basic situation, and then the hydrochloric acid would be for acidic. Now, what a lot of people made the assumption, which was kind of a good thing to see, because a lot of you thought that, well, because it's neutral, that must be the preferred pH, and you don't really know that. So what you needed to do is treat the distilled water trial number 1 as if it was any other. It's a variable, right? Because this has a pH of 7 roughly, this has a pH of like 2 roughly, and then this one is more like 11. All right, or actually probably more like 13. So there's that. All right, more around 13, maybe a little higher. Acid, maybe a little lower, right? But in either case, those were the approximate pHs for your lab, and that was your independent variable. So that's what we changed, and then of course our dependent variable is finding out whether or not the sucrase was had undergone hydrolysis to form the glucose and the glucose and the lactose, the glucose and the fructose. Now, the last 3 I put in there because there are some things we have to rule out. We need to rule out things like the we want to make sure like sucrose in and of itself, right? What if sucrose in the presence of water will naturally break down and form the fructose and the glucose? We don't know that, so what we have to do is we have to test that, and we have to rule out sucrose being something that will just break apart on its own, given it's in heat. Like because we're adding heat to all of these things, maybe the heat is just enough to cause the sucrose to break apart. Okay, so we want to rule out, so to speak, rule out sucrose as being something that will just break apart on its own, and the invertase had nothing to do with it. Okay, likewise, in a tube, oops, let's get rid of that. In the tube 5, I would put invertase in there with some water. And this is just to rule out the fact that if there is a color change that occurs, we want to make sure that the invertase isn't the component that breaks down and causes the color change when you add the Benedict solution. Because we're adding Benedict solution to all these eventually, right? We are going to allow them to rest or incubate, okay, before adding the Benedict solution. We're going to allow them to incubate for about 10 minutes at 37 degrees Celsius, okay, so roughly our body temperature, all right? And the last tube is just water. And the reason why I'm doing this is because I want to know clearly what a negative Benedict's test would look like, right? So I'm going to put a Benedict's test here, right? We're going to add Benedicts to them after they've all incubated, but I want to make sure that, you know, water, water isn't going to react with the Benedict solution to cause a color change. Now, this right here can be, you can omit the sixth tube, but I like to kind of put that one in there just so you guys can see a true negative control, right? So there's no sucrose, there's no invertase, so we know that the Benedict solution and the water, and that's all that's in there, so we can see how water reacts with the Benedict tube, or with the Benedict's test, okay, or Benedict solution, excuse me. All right. Now, it's important to note that we're going to have some fixed volumes here. A lot of you were kind of all over the place with your volumes, and again, that's fine. That's all about how you guys did your protocol. If you had, you know, added 5 mils and 5 mils and 15 mils and 15 mils, then so be it. Of course, like I said, my one parameter was don't run out of stuff. And, you know, all of you didn't, and that's fine. So what we're going to do for tomorrow is we're going to do this lab. We're going to do these tubes 1 through 6. And then once I've added all these things to the tubes, okay, so I've added the invertase, sucrose, and water or acid or base, okay, depending on the situation we're in, we're going to let them incubate, okay? So we will allow them to incubate. So we're going to incubate in the tubes and just have them in the tubes in the rack themselves, and we'll just stick the whole rack in the incubator. Okay, incubate at 37 degrees Celsius, which is our body temperature, for, we'll go 10 minutes, okay? Plus or minus 2. I'm sure 8 to 12 minutes will be fine, okay? Then, once we've let them incubate, in doing so, by having them incubate, we're allowing, if the invertase does in fact act on the sucrose, we want to give that enzyme time to work, okay? Now, the reason why we put all the tubes in there is because if we don't want to treat one tube different than another, we want to make sure we can minimize our variables as much as possible. Okay, so yeah, we are going to incubate for 10 minutes at 37 degrees Celsius, and then the next thing we're going to do is we're going to add the Benedict solution. Now, how much you're going to add, okay? That is really going to be dependent on the amount of the stuff that we have in the tube. So my recommendation is we're going to add one milliliter of the Benedict solution. Now, to kind of go back on our last slide as far as how much of each thing do I want to add to the tubes. Okay, my apologies for that. For tube 1, right, we're going to add 3 mils of each the invertase and 3 mils of the sucrose. And then we're also going to add 1 mil of the water. So for a grand total of 7 milliliters of solution in the tubes before we add the 1 milliliter of Benedict solution. So by the time it's all said and done, we should have a grand total of 8 mils in each tube. Okay, so for 2, just so you guys can see, in fact, I'll go ahead and pause the video and then write them all out, and then I'll start recording again, just so it's easier for you to write down. You can always pause the video instead of listening to me write. Alright, so they're all written out. Go ahead and pause the video so you can write down what's going to go in each tube. Alright, so now that we know what's going to go in each tube, plus we add that 1 milliliter of Benedict solution, it is then going to go into the water bath. And really, it shouldn't be in the water bath for more than 5 to 7 minutes. Okay, you should start seeing results change, or start seeing its color change around 5 minutes. Again, make sure that your water is close to boiling point, okay? You don't want it to be a rapid boil, okay? If you have a nice slow boil, that's perfect. Okay, make sure there's enough water in there to submerge your solutions totally, but even if you're up a centimeter or two above the lip of the water, then you should be fine. Okay, so again, like I said, I hope we didn't get too frustrated today, and by no means I hope we didn't get embarrassed, because you're gonna screw up in this class, okay? And that's fine. That's gonna happen. It's gonna screw up. You're gonna screw up a lot. Not just here, but when you go to college and you take those science classes, and when things don't go right, all you can do is, well, do what we're doing. We're gonna do it again, and that's science.